This video we're going to talk about how to monitor the rate of reaction by measuring the change in mass of the system. Like previous videos, this one will also be focusing on the physical properties. So this time, we will measure the change in mass, and in process, we'll have some gas product form, and these gas products have to be heavier, not very light. So that's why hydrogen will not be part of the options for that. So for following progress of the reactions, we have to measure the change in mass of the reaction mixture with electronic balance, to measure the mass, because we need to at regular time interval. So not only beginning and also at the end, measure the mass change, but in the process, we have to know that how fast, the mass have been leaving from the system. So we're going to use this setup to help. When we have, like what we mentioned, we need gas produced in the process. But remember, the gas produced, it can't be as light as hydrogen, because hydrogen has a very low density. So even hydrogen leave the system, the electron balance, the reading in the electron balance cannot be shown clearly. The decrease in the mass will be insignificant for that. So the example that we have today, it will be the marble react with the exit. So in the process, you see that carbon dioxide is leaving from the system. So basically, with the setup, you can see that we are not using a normal stopper for the conical flask. Instead, we are having a cotton wool plug. Cotton wool plug have some gap in between. So therefore, if the reaction they generate carbon dioxide, the carbon dioxide can leave from the system. So the exit, we have HCl, we have added in the conical flask, and then we have add the limestone, into it directly. So in the process, remember you need a timer to help you to take the time, see how long the experiment have been going through. So as time goes by, you expect the mass of it, because carbon dioxide leaving from the system, the mass of it have to be decreasing as time goes by. So it should be lower than 147.3 gram in this case. So you need to sketch the setup, for this one. So what you need to do, just draw a conical flask, and in a conical flask you have HCl. Not only this, you can also draw the calcium carbonate in it as well. So the calcium carbonate will be like that. So you have a cotton wool plug, and you also need to have a electronic balance. So you have a electronic balance, and most important, you also need a timer. So you need a timer to measure the time having passed for the reactions. So basically the sketch, you have to sketch the setup, very important, about 2 marks for this one. So why there is a decrease in mass of flask, as I've mentioned, because there is an escape of CO2 produced, so therefore they will decrease in mass of the flask. CO2 have mass, so when it leaves the system, the total mass of the whole reaction mixture will decrease. So what is the function for cotton wool plug? There are 2 parts of the function. The first one, they allow the escape of CO2. If you're using stopper, actually you cannot do that, but you can say that then I don't use cotton wool plug, actually the CO2 can also be escaping. So the other functions for cotton wool plug is to prevent exit from splashing out, because you know that in the process bubbles is coming out, is releasing in the process. If you don't have something to stop the exit jumping out, actually the exit splashing out, it will cause a great decrease in the mass. So then that will affect the results. So basically, the function of the cotton wool plug is very important. So what is the limitation for this setup? As I've mentioned before, this setup is not suitable for the gas production, which produce very light gas. So this one cannot be used to determine like hydrogen, because hydrogen is a very low density. So because they have a very low density, change in mass of the reaction mixture is too small to be detected by the electronic balance. So if we're just using the electronic balance in the school lab, actually it is not accurate enough to or sensitive enough to measure these changes. So therefore for hydrogen, we are not preferable to using this setup. So the procedure basically, you need to put a conical flask, okay, containing the acid on the electronic balance. To start the reaction, basically you just pour the limestone into the acid and start the stopwatch. Remember, you have to replace the cotton wool immediately, so therefore, okay, it can prevent the acid from splashing out. What you need to do is just record the mass of the flask at regular time interval throughout the whole reactions. Okay, so if you want to have a look of the experiments, you can scan this QR code to have a look of it. So just have a look of examples right here. So when you got the tables, first of all, what you have to do, you have to find the end of the reaction. So it will be 7 minutes, so 146.3 gram. So the decrease in it will be 150 minus 146.3. Okay, so it will be around like 3.7 gram right there. Okay, so that will be the loss. This 3.7 gram will be equivalent to the mass of carbon dioxide leaving, okay, from the system, okay, because we have carbon dioxide produced here. So plot a graph, okay, to show the total mass of flask and its content. So the mass is decreasing, okay. So remember, y-axis will be the dependent variable. So the total mass with gram will be the y-axis, and time in minute will be the x-axis. So you can see that it starts from 150, okay, and then all the time it goes down. So for the y-axis, you may also want to have these symbols, okay, to cut short, okay, the distance between 0 to 146 gram. Okay, so basically for this one, okay, what is the purpose of putting the cotton wool plug? As I mentioned, allow the escape of carbon dioxide, at the same time prevent acid from splashing out. So that will be set up like this. So if you want to look for a average rate, then you may need to have this point and this point to find out the rate. But this question, it doesn't ask about that. So another example, okay, class practice 36.7. So this time, okay, you also need to referring to the table, okay, in the previous slide, okay. So you'll find that you have to calculate the mass of carbon dioxide produced. So this table is not difficult for you to measure, okay, for you to fill in, okay. So this time, okay, you need to plot a graph, mass of CO2 produced. So this will be the y-axis for this, and then the x-axis will be the time of reactions. So remember, you have to mark the total mass of CO2 produced and also end of reaction. These 2 points are 2 of the 4 important points in the graph that I mentioned. So mass of carbon dioxide produced, actually we're going to plot a product time graph. So so you can see the product time graph here, okay. So you have mass of carbon dioxide produced, that will be y-axis, time will be minute, okay. And remember, you have to mark the 2 points, okay. One will be the total mass of carbon dioxide produced, and the other one going down, that will be the total time of the reactions, okay. So that will be like this. Forgot part A, okay, what caused the decrease in mass of flask? As I mentioned, it is because of escape of carbon dioxide. Okay, so leaving of carbon dioxide, it will cause decrease in the mass. So B is to fill up the table, C is plotting the graph, D, what is the initial rate? Remember, to measure the initial rate, you have to draw a tangent, and then the slope of the tangent will be the initial rate. So remember, when you draw a tangent, you have to mention the tangent should be, draw a tangent at t equals to 0. Okay, this is something that you have to mention. Okay, so you can see, draw a tangent at t equals to 0. Then the slope of the tangent, it will be the initial rate. Okay, so initial rate, we just have 1 point. Okay, something like this. Okay, so how can we have 2-point form? Any point of this slope can be used. Any point at this tangent can be used as a 2 point. So maybe you can use in this one, maybe using this one, maybe using the origin one. Okay, both any one of them will be all right. Just use 2 point. Okay, can help you find the initial rate. Calculate the average rate. If you're talking about average rate, okay, I prefer not to refer to the tables, not refer to the graph. You use the data right here. So use the data here, 3.7 over 7. Okay, so that will be the average rate. So it will be 0.53 gram per minute. Okay, so that will be another example. So to summarize the videos, so you have to know that measure the change in mass of reaction mixture with instrument that will be electronic balance at regular time interval. This is how we suggest to monitor the rate of reaction. When you use it, okay, or when there is a gas produced, but remember the gas cannot be hydrogen because that will be too light, low density. Okay, so why the mass will decrease? Because there is an escape of gas, so result in a decrease in mass of the reaction. And we also use Co2 Muplot here. There are two functions. The first one is to prevent splashing out of the exit. The second one, at the same time, they allow the gas to escape. Lastly, the limitation we have mentioned, no hydrogen, too light to be detected. Okay, remember you have to sketch the setup, okay, for these experiments. Okay, so basically the whole video will be like this. That's all for this video. Bye bye.